definitions again, because I forgot. All right, we're looking at lesson 48 today. Indirect proofs. So direct reasoning, the process of reasoning that begins with a true hypothesis and builds a logical argument to show that a conclusion is true. Y'all got that? So that's what we've been doing. Those are the paragraph proofs, the flowcharts, and the two-column proofs. Or it says, explain this. Like, that's what you've been doing. What we're going to look at are indirect proofs. A proof in which the statement to be proved is assumed to be false and a contradiction is shown. And then proof by contradiction, it's another name for indirect proofs. There are 3 steps to write an indirect proof. 3, that's it. You do these 3 steps every time, and that's all you have to do. One, you assume the conclusion is false. Whatever they want you to prove, you assume that it is false. And then you show that the assumption you made is contradicted by some theorem, definition, postulate, or given information that they give you. And then you state that since the assumption must be false, your conclusion has to be true. Okay, this one is like really basic. There's really not much we're going to do with this one. But as an example, they give you x equals 1, and you're supposed to prove x equals 1. Well, there's not really a proof there, but it's just an example, okay? So first, you assume that the conclusion is false. So what is our conclusion? What do they want us to prove? They say x equals 1, right? But we say that is false. So x does not equal 1. Does that make sense? And then they say, show that that can't be true. Like, find a contradiction. Find a counterexample. Well, given information says x equals 1, right? So, therefore, since x does not equal 1 is false, or since it's contradicted, x must equal 1. Does that make sense? That's the basic idea of what we're doing with these. I like these the best. I don't know why.
Yeah. Yeah.
I don't know. I just think these are the easiest of all of them. I mean, obviously that is not an example that they're going to give you, but that's the concept. Okay, so here's an example. We are supposed to prove theorem 4(2). If there is a line and a point not on the line, then exactly one plane contains them. There will be a little bit of writing for these, but they're not conceptually difficult. Okay, so you will have to write more than you would think, but they're not conceptually difficult. You each have a little bit more writing than you probably would like. Did you know this is geometry/English? Okay, so first you do your assume. And I want you to do one and then assume so that you remember what step one is. What are we supposed to assume? What are they wanting us to prove? That theorem 4-2, right? So what do we say? Okay, that's one way to word it. If there is a line and a point not on a line, then not exactly one plane contains them. Or they say assume A, B, line A, B, and non-collinear point C are not contained by exactly one plane. So you can use letters if you want and things. You don't have to. So assume. So that's what I wrote for that. You can word it differently, but it needs to be the same. I like to say both theorem 4-2 is false and then say the statement and put it as being false. Does that make sense? That's just a preference because I like to be very specific in my proofs if I can. And so I do both. Do not just say theorem 4-2 is false. You need to actually say what theorem 4-2 is. Okay? So if you just put this part right here, that's not enough. Okay? What does that contradict? You cannot use theorem 4-2 in your proof. Nice try. Okay, what is that? No, we're not dealing with triangles. Brian says a plane postulate. You don't have to know the number, but what does it say?
It's the one that states that
Three non-collinear lines make a plane? Okay. 3 non-collinear points make up a plane, which is actually postulate 9. It tells me that. It's the only reason I know that. Okay. So, this contradicts, you can say postulate 9 if you know it, but you're still going to have to say what the postulate is. Does that make sense? So if you know the number, you can put it. You don't have to. I show it contradicts a postulate. Do what? So what does that postulate state? 3 non-collinear points. What about the points? Define exactly one point. Does that make sense? So that is our contradiction. Therefore, what? Therefore, our assumption that that theorem is false. You could say is false, but I don't want to say is false, so I'm going to say is not true. So our assumption is true. Wait, no. So not our assumption. So theorem 4.2 is true. Does that make sense? Which means that if there is a line and a point not on the line, which means that the theorem has to be true. Does that make sense? Do y'all see how that works? It's a lot of writing. You're repeating yourself over and over again, basically. But that's all you have to do for those 3 steps. Assume, contradict, therefore. No, I think they're easy. All right, looking at another example. What are we going to assume? Okay, so if this is false, they are not congruent, they are congruent. Does that make sense? Y'all see how that works? Okay. What is that going to contradict? No. Definition of median? What do we know about a median? Okay, so if Ln were the median, what would that mean? What? Yeah, if Ln were the median, Pn and Mn would be congruent. Does that make sense? But Ln is not the median, right? So what does that mean? That they are not congruent. Okay, so if the 2 triangles are congruent, that would mean that this side and that side are congruent, which they are, that side and that side, that means that that side is congruent, which it is, because it's a reflection of itself. That means that this angle and that angle are congruent, and that angle and that angle and that angle and that angle, and then that side and that side are congruent, right? All of that. But we know that one of those is not true. Mainly, we know that this side and this side are not congruent, correct? Okay, so by CPCTC, congruent parts of corresponding parts of congruent triangles are congruent. Does that make sense? By CPCTC, if the triangles are congruent, that would be true, right? Does that make sense? But what does that contradict? Does that make sense? Since LN is not a median, what does that mean? Those two cannot be congruent, which makes your contradiction. Does that make sense? Therefore, what? So our assumption that the two triangles are congruent is false. So the triangles are not congruent. Does that make sense? You need to make sure that you say our assumption is false, therefore this. So our assumption is false, therefore whatever they said to prove. Y'all see how that works? Okay, what are the three parts to an indirect proof? Part one, assume what? Conclusion is false. Whatever they ask you to prove is false. Then what? Find a contradiction. How are you going to find a contradiction? What do you use? Theorems, postulate, definitions, or the given information. And then third step, therefore, our assumption is wrong, so the conclusion is correct. Does that make sense? Okay.